In today's video, we're going to talk about Legendre differential equations. In this equation, we have a question here which is stated that 2x plus 3 whole square d square y by dx square plus 2 into 2x plus 3 plus 3y is equal to e of z. So we make an auxiliary equation out of it. That will become 2 square that comes from here, square comes from here. When we have one thing is very important, that when we have d square y by dx square, we write here as d into d minus 1, and like here when we have only the same thing with power 1, we write only a d, like it's written here 2, this 2, the 2 from here, like that, 2 into 2 into d, the d for this equation, plus 3, we got a whole y is equal to 0. So as we are making an auxiliary auxiliary equation, we will multiply this simply as which will become 4d square minus 4d plus 4d is equal to 3, and that is the whole y is equal to 0. The y becomes 0 when it's divided here, and the rest becomes d square is equal to minus 3 by 4, which becomes d is equal to root of minus 3 divided by 2. So here we've got a number which is plus minus root 3 I upon 2. So now we we write here as e of z is equal to 2x plus 3. So when we applied natural log, it will become z is equal to ln of 2x plus 3. So here now we've got to find the yc of this equation. The yc of this equation is as this, we have a I in here, so e of 0z, as there is no power e, and c1 cos root 3 by 2x 3 by 2 z plus c2 sine 3 by 2 z. Okay, now you're gonna simplify it. Let's realign the papers, sorry for that. Yes, now we're gonna substitute the value of z into this equation, which will become c1 cos root 3 by 2 ln of 2x plus 3, which is written here like z is equal to ln 2x plus 3. We have substituted the value of z, ln 2x plus 3 plus c2 sine root 3 by 2 ln 2x plus 3. Okay, so we have established here the value of yp. So now we're gonna find yp. Finding yp is a little difficult than finding yc, but it's not that hectic. So for yp we can establish that 1 upon 4d square plus 3, the auxiliary equation, into x square. Yp is equal to that. So as we know that the value of x is equal to ez minus 3 divided by 2, so we are putting the value of x into this equation yp. So the equation becomes 1 upon 4d square plus 3 into e of x minus 3 upon 2 whole square. The square comes from this. So we're now going to simplify it. 1 upon 4d square plus 3 into, we're going to open the square, we're going to do the squaring, which will become e of 2z plus minus 6 e of z plus 9 upon 4. So now we're going to open it up. 1 upon 4d square plus 3 into e of 2z upon 4 minus 3 upon 2 e of z plus 9 upon 4 e of 0z. Basically there is no e, so we're gonna write e of 0z as e of 0 is equal to 1. So yp here will become, we're gonna multiply it with each of them. This becomes 1 upon 4 into 2. The thing is, the power of e is put into this d. The power of e is basically the value of d with each one. So 1 upon 4 into 2 plus 3 is into e of 2z upon 4 minus 1 upon 4 into 1. There is no value except 1. There is only z, so we'll put the value 1 in here. 1 upon 4 into 1 square plus 3 into 3 upon 2 e of z plus 1 upon 4 into 0 plus 3, because there is no value of e, so we'll put in as 0. 9e 0z upon 4. We're going to simplify it now. It becomes e of 2z upon 19 into 4 minus 3e of z upon 7 into 2 plus 9e of 0z upon 12, and we're just simplifying it now. There's nothing else. E of 2z upon 76 minus 3e of z upon 14 plus 3 upon 4. Now we're going to replace it by e of z. This is the most important part of the question. We have to replace e of z, and if we leave that, the question is not the answer is not complete solution. Yp will become 2x plus 3 whole square upon 76 minus 3 into 2x plus 3 upon 14 plus 3 upon 4, and this will be the answer to our Legendre equation.